Hello students, welcome to physics classes. I am Sardeep Kaur Sidhu here. So today we will discuss the topic of BSc first semester, that is equation of damped mechanical oscillator and its solution. Yeah. So first of all, what is mechanical oscillator? You know that when a mass is attached to a spring, then that oscillator becomes mechanical oscillator. That oscillator becomes mechanical oscillator when it oscillates with two positions are extreme positions, means from mean to extreme, then to mean, again to extreme, then to mean, with the help of inertia and elasticity, that we have discussed in the previous lecture of mechanical oscillator in detail. So I will not go to the detail of that topic. So but here is the new term, that is damped. So damped means damping. What is damping? You have studied in +1 that what is damping? When amplitude of the wave decreases with the passage of time, then damping occurs. Clear? And with, for example, if this is a undamped oscillator, the equation, the wave for this is like this. The amplitude is same throughout. Okay? And this is x and this is t. So amplitude doesn't changes. This is for undamped. And if this equation is for damped, then amplitude is like this. Amplitude is like this. It decreases with the passage of time. It decreases with the passage of time. Yes. And sometime it comes to 0. So amplitude decreases with the passage of time, that is damping. Clear? So damping is directly proportional to damping occurs when amplitude decreases, but we know that energy is directly proportional to amplitude square. In mechanical oscillator, in the last lecture we have done amplitude square. If amplitude decreases, then energy decreases, and if energy decreases means there is a dissipation of energy. Energy decreases means there is a dissipation of energy. If there is a dissipation of energy, then damping occurs. So, but with which factors damping occurs? So damping is due to so many factors in the case of mechanical oscillator, that is due to viscous drag, resistive force and other factors. So a damping force, you can say that Ft means damping force. This is also called resistive force. This is also called resistive force, and this is directly proportional to velocity. This is directly proportional to velocity. So Ft is equal to minus R dx over dt. Now this is new term, constant of proportionality. Minus sign shows that it opposes the acceleration of the mass. R. What is R? R is damping constant. R is damping constant. And if you want to find out the units of R, you can find out. R is equal to force by velocity, and the units of force is Newton, and the units of velocity is meter per second. So you can find out the value units of R. Clear? So minus sign shows opposition. Clear? So this is damping force. Take it equation number first. Now you know that when particle is at extreme position, a force comes which wants that particle always remains in the mean position, and that force is restoring force. So F is equal to minus Sx, as we have done in the previous lecture, minus Sx. Clear? S is spring constant, or you can say that it is stiffness constant. So this equation is, take it equation number second. So this is new term, additional term in this case, in the case of damped mechanical oscillator. Clear? So when we join these two equations, we get net force, that is equal to minus R derivative of x with respect to t minus Sx. So this is net force, F net. Clear ji? And this force must be equal to Newton's, according to Newton's second law, this force is equal to mass into acceleration. So we take here mass into acceleration, double derivative of x with respect to t square. Now divide the whole equation by m. When you divide the whole equation by m, this m cancels, r by m, s by m. So this means I put here double derivative of x with respect to t square and I put r by m. So put r by m, that is equal to another constant 2b. This is also because we add only 2 here. So b is also a damping constant, another damping constant. So r by m and put s by m. You know what is s by m? That is equal to omega naught square. That is equal to omega naught square. That is the angular frequency for undamped mechanical oscillator. Angular frequency for undamped mechanical oscillator. So double derivative, when you put all the values here and taking this equation in left side, these two parts. So double derivative of x with respect to t square plus r by m, that is 2b. 2b single derivative of x with respect to t minus s over m plus हो गया बेटे plus omega naught square x, that is equal to 0. So this is about the equation of motion for a damped mechanical oscillator. So this is Rajesh equation of motion. Now if you want the solution of this equation, put x is equal to, let's take the x is a solution of this differential equation. X is equal to a e raised to power alpha t. So when we take the first derivative, because we have to put the first derivative and second derivative, because if this is the solution of this equation, this x must satisfy this equation. So single derivative of x with respect to t, that is equal to a e raised to power alpha t, constant alpha multiply, then double derivative of x with respect to t, that is equal to a alpha e raised to power alpha t alpha square. Clear ji? So this is the values. When we put, now you have to put these two values in this equation. When you put these values in this equation, what you get? A alpha square e raised to power alpha t, yeah, plus 2b a alpha e raised to power alpha t plus omega naught square x a e raised to power alpha t, that is equal to 0. So we get this. Clear? When you get this, now cancel the terms. A goes, e raised to power goes, a goes, e raised to power goes. So these terms goes. So what you get? Alpha square plus 2b alpha plus omega naught square, that is equal to 0. That is equal to 0. So this is a quadratic equation in alpha. So find out the roots. Alpha is equal to plus minus b. Minus b. Minus b means minus 2b plus minus b square. B square means 4b square. This is 4b square minus 4ac. 2 means 4, 4b square minus 4, 1 omega square. Clear? Divided by 2a, 2. So 2, 2, 4 बार आगे 2 आ गया बेटा और 2, 2 ना 2, 2 कैंसिल हो जाना. What you get? b plus minus b square minus omega naught square. Nothing, because 4 बार आगे 2 हो जाना. 2, 2, 2 है 2 खत्म हो गया. So minus b plus minus b square minus omega square under root. This is alpha. Here, but here are two values of alpha. One is in plus sign and another is in minus sign. But we have x is equal to a e raised to power alpha t. So to put these two values here, we extend it. How we can extend it? We can. So how we can extend it? We have x is equal to a e raised to power alpha t. But alpha have two values, so we can write here x is equal to a1, because a and a1 both are constant, e raised to power alpha 1 t plus a2 e raised to power alpha 2 t. So put the values beta. a1 e raised to power alpha 1 t. Alpha 1 t means e raised to power minus b plus minus plus b square minus omega naught square into t. Clear ji? Plus a2 this e raised to power alpha 2. Alpha 2 means minus sign वाला आ गया. So minus b square minus omega naught square t with whole. So here is also t with whole. So you can take e raised to power. So x is equal to a1. So this is all about this x. So next we will done in the next lecture about 3 types of damping. So this is the equation of damped mechanical oscillator. So you have new term that is 2b. ठीक है? So 2b is equal to r by term. This is very important question. Sometimes come in the exams. So b is equal to r by 2n. So याद रखना बच्चे, b is equal to r by 2n. So the differential equation and its solution. Thank you.